I want to go through the second activity worksheet for section 2.3 on the product and quotient rules. So if you want to have some extra practice, you can see how to do these because most of you did not get to this in class. So we need to remind ourselves what the product and quotient rules are. So up here, if f and g are differentiable functions, then the derivative of f of x times g of x is f prime of x times g of x plus f of x times g prime of x. And also the derivative of f of x divided by g of x, that's the quotient, that's a derivative of a quotient, is f prime of x times g of x minus f of x times g prime of x, all divided by g of x squared. So those are our two rules. So let's see them in action. So this says that f of r equals 5r cubed plus sine of r times 4 to the r minus 2 cosine of r, and we want to find f prime of 0. So in order to find f prime of 0, we need to have a formula for f prime of r first and then input 0. We cannot input 0 first and then take the derivative. We have to find a formula for the derivative first and then input 0. So let's do this. Here we should see that we actually have two functions being multiplied together. 5r cubed plus sine of r, that's our first function, times 4 to the r minus 2 cosine of r, that's our second function. So we have a product overall, so let's use our product rule. So this tells us that f prime of r equals, we're going to take the derivative of the first function, so we get 15r squared plus cosine of r, that's a plus sign, times the second function, we leave that alone, 4 to the r minus 2 cosine of r, plus, I'm going to have to go on a different line here, we take the derivative of the second function, we leave the first function alone, 5r cubed plus sine of r, and multiply by the derivative of the second function, 4 to the r natural log of 4 plus 2 sine of r. Okay, and there is f prime of r. Now we need to find f prime of 0, which amounts to everywhere where there's an r, we're going to input 0. So where am I going to put this? F prime of 0, that equals 15 times 0 plus cosine of 0. What's cosine of 0? It is 1 times 4 to the 0 minus 2 cosine of 0, which is 2 times 1, plus 5 times 0 cubed plus sine of 0. Sine of 0 is 0. And times, and actually you should notice right here that this factor here is already 0, so no matter what we multiply it by, we're going to get 0 anyways. But just so we can be complete, we get 4 to the 0 natural log of 4 plus 2 times 0, which is 0. Okay. And after we work all of that out, we should get 0 plus 1 is 1 times 2, 1 minus 2 is negative 1 plus 0 times natural log of 4. And so overall we get negative 1. So f prime of 0 is negative 1. All right. So now I'm going to erase all of this so I have more room to do the next problem. All All right, I got smart and I zoomed in to give myself more room. So here's the next problem. Feel free to just skip ahead and move around to see what the answers are. If you've already tried all of this, this is just for your extra practice. So we have p of t equals cosine of t over t to the 6 times 6 to the t, and we want to find p prime of t. So we have two fundamental operations going on here. We have division and multiplication. So the question is, what do we start with? Or in other words, what's the fundamental operation here? So if you think about the order of operations, we really want to know what is the last thing that you would do. Would you do the multiplication first, or would you do the division first? Well, if you put it a t value, we would compute cosine of t, and then we would compute t to the 6th times 6 to the t, and then after we had found both of those values, then we would do the division. So this division right here, that is really the last thing we would do, and that is our fundamental operation. So we're going to start with the quotient rule. So to find p prime of t, we need to use the quotient rule, which tells us first we find the derivative of the numerator, that is negative sine of t, and we leave the denominator alone and multiply by it. And then we subtract cosine of t, and now we take the derivative of the denominator. So we have to figure out the derivative of t to the 6th times 6 to the t. Now don't be fooled and say 6t to the 5th times 6 to the t natural log of 6. We can't just take the derivative of each piece separately and multiply them together. We also need to use a quotient rule. So we need to do 6t to the 5th times 6 to the t plus, I've run out of room, t to the 6th times 6 to the t times, let's back up a little bit, give myself a little bit more, t to the 6th times 6 to the t times the natural log of 6. Okay, and now all of that, if I had more room, put it all in one line, divided by t to the 6th times 6 to the t squared. And there's my derivative. I can leave it like this. I do not have to simplify it. You can if you want to, but you do not have to. Okay, just leave it there. All right, here's the last problem on this side. And we have this very long function. G of z is 3 times z to the 7th e to the z minus 2z squared sine of z plus z over z squared plus 1. So notice we have three different terms on this problem. Overall, this is the sum. So we're going to use a sum rule, which means we can take the derivative of each term separately and then add them together. Okay, and then each term we'll deal with and see if is it a product, is it a quotient, is it a power function, what is it? So here's our first term. We want to take the derivative of this, so g prime of z. This equals, now the 3 is a constant, so we bring that down, times the derivative of z to the 7th e to the z. Alternatively, you can think of 3z to the 7th as your first function and e to the z as your second function. So let's take 3 times the derivative of z to the 7th, so 7z to the 6th times e to the z. So we took the derivative of the first part and left the second part alone, plus 3z to the 7th, we leave the first part alone, times the derivative of the second, which is e to the z. I know that was a little bit confusing because right here, e to the z was the original function, and right here was the derivative of e to the z. Taking the derivative of e to the z can end up being kind of confusing sometimes. All right, so now here we're going to start taking the derivative of this term. So again, overall we have a product. let's think of negative 2z squared as our first function and sine of z as our second function. Okay, so let's take the derivative of the first function. We get minus 4z, and we leave the second function alone. All right, I'm going to go to a new line. The next thing we're going to do is leave the first function alone, negative 2z squared, and take the derivative of the second function, cosine of z. All right, so now we've taken the derivative of all of that term. So, oh, I didn't mean to do that. All right, and now we have this last term to deal with. And the fundamental operation here is a quotient, where our numerator is our first function, z, and our denominator is our second function, z squared plus 1. So, how do we do this? The quotient rule says we take the derivative of the numerator first, times the derivative of times the denominator, minus what we get when we leave the first function alone, times the derivative of the denominator, all divided by the denominator squared. All right, and now we have taken the derivative of all of g. Okay, so it is this very, very long thing. We get 3 times 7z to the 6 times e to the z, plus 3z to the 7th times e to the z, minus 4z sine of z, minus 2z squared cosine of z, plus 1 times z squared minus z times 2z all over z squared plus 1 squared. Okay, all of that. Leave it like that. Don't try to simplify it. This is enough. All right, we're going to keep going. And, oh, I've got to move on and zoom out a little bit. Okay, so here we have, we've got two differentiable functions, f of x and g of x, and we only know this data about it. F of 3 equals negative 2, f prime of 3 equals 7, g of 3 equals 4, and g prime of 3 equals negative 1. And we've got this new function, p of x, it's f of x times g of x, and we want to find p prime. I think that cut me off. We want to find p prime of 3. Okay, so if I want to compute p prime of 3, first I need to figure out what p prime of x is. So I write down that p of x, well, it equals f of x times g of x. And then I realize, well, p of x is a product. It's f of x times g of x, so I can use the product rule in order to find the derivative. So let me do that. All right, I have this formula right here. So p prime of x, that's going to be f prime of x times g of x plus f of x times g prime of x. Well, actually, this is great because I'm looking for p prime of 3, and that is f prime of 3 times g of 3 plus f of 3 times g prime of 3. And I know all of those values. They're up here. F prime of 3 is 7, and g of 3 is 4. Plus f of 3 is negative 2, and g prime of 3 is negative 1. So total, I have 28 plus 2, which is 30. And there's my answer. All right. Let's do the same thing for this other function, q of x, because we want to find q prime of 3. So again, in order to find q prime of x, I look here at the definition and I realize that q of x is a quotient. So in order to find the derivative, I do f prime of x times g of x minus f of x times g prime of x divided by g of x squared. So q prime of 3 is going to be f prime of 3 times g of 3 minus f of 3 times g prime of 3 all over g of 3 squared. And so we input the values we know. I'm going to write them down here at the bottom because I will erase it before I do the applications problem. So f prime of 3 is 7, just like before, and g of 3 is 4, minus f of 3 is negative 2, and g prime of 3 is negative 1, all over g of 3 is 4, so I get 4 squared. So I get 28 minus 2 over 16, which is 26 over 16, or 13/8. Okay. So, last question. We're going to move on to this applications question. All right, here we have a moving particle, and it has position in feet at time t in seconds, and it's given by this function s of t, and it is 3 cosine of t minus sine of t all over e to the t. And we want to find the particle's instantaneous velocity at moment t equals 1. Instantaneous velocity should signal to you that's the derivative of the position function. And we are given the position function, so that's what we want. We want s prime of 1. So in order to find s prime of 1, we better find s prime of t. And looking at s of t, the fundamental structure of that function is a quotient. That's sort of the last thing you would do in order of operations. So we're going to use the quotient rule. So to use the quotient rule, the first thing we need to do is take the derivative of the numerator. So the derivative of the numerator, we've got a difference there. So we can take the derivative of each part separately. So we should get negative 3 sine of t minus cosine of t times, we leave e to the t, we leave that denominator alone, minus, well this time we're going to leave the numerator alone, 3 cosine t minus sine of t, I'm running out of room, times the derivative of the denominator, and the derivative of the denominator is actually e to the t again. We get all divided by e to the t squared. At this point, you might notice that some of these e to the t's will cancel. So you don't have to do this, but you might notice that there's an e to the t in both terms in the numerator, and that it will actually factor all the way out, and it will cancel with one of the e to the t's in the denominator. So we should get negative 3 sine t minus cosine t minus 3 cosine t plus sine t, all divided by e to the t. So simplifying a little bit more, we get negative 2 sine t minus 4 cosine t, all over e to the t. Notice you didn't have to do this simplifying, or you could have just as easily have gotten this from the first derivative we came up with, this one at the top. So now that we want to find s prime of 1, we can't forget that. Okay, so we get negative 2, didn't mean to do that, negative 2 sine of 1 minus 4 cosine of 1, all divided by e to the first power. And so this problem is a word problem. If we wanted an exact answer, this would be our exact answer and our units would be feet per second. Many times in a word problem we actually do want an approximation. So let's go ahead and approximate this. So I get approximately negative 1.4114 feet per second. And so what that would mean, that negative, means that the particle is probably moving to the left at 1.414 feet per second. That's a feet per second at t equals 1 second. Okay, make sure that your calculator is in radians when you calculate this. All right, let me know if you have any questions on any of this. Again, try this for extra practice. It is not homework, it is just extra practice. All right.